Hi everyone, so now today we're going to be solving 6.2 and 6.3 quizzes for Math IGCSE for our periodic. So let's start. This is the 6.2 quiz. 6.2. And yeah, it has 11 questions, not that hard. Oops. So let's start. So the first question, it's telling you that you have a chess player that plays 2 games of chess against a computer. The probability of him winning the first game is 0.6 and the probability of him winning the second is 0.8. Assume that the outcome doesn't depend on the other game. So what's the probability of winning both games? So if his probability for winning first one is, he could either win or lose in this case, right? So the probability of him winning or losing first game here, it's 0.6. And here it's whatever is left of 0.6. So the chance he loses the first game is 0.4. So you have to do 1 minus 0.6, then you get what's your chance of losing. Now when he plays again, he could either again win or lose. So they told you the probability of him winning the second game is 0.8. And it doesn't matter if he lost the first game or won it. And his probability of losing again is 0.2 because 1 minus 0.8 is 0.2. So let's do that again because 0.8, 0.2, win, lose. So now that we drew our tree diagram, what's the probability of winning both games? So win, what's your probability of WW? If you get it written, write it like this. Probability of WW equals 0.6 times 0.8, which when you do it on your calculator, you're gonna get your answer to be 0.48. So that's how you get the first one's answer. Now, for part B, they're asking you what's the probability of losing both games. So what's the probability of lose-lose? It's equal to 0.4 times 0.2. So 0.4 times 0.2 equals 0.08 if you do it on your calculator, because calculators are definitely allowed. What's the probability of winning exactly one game? Which means what's the probability of win-lose, lose-win, what's the probability of win-lose or win-win? So for this one, you are gonna have to do the probability of winning. But wait, let me check something on my calculator really quick. Okay, plus the probability of win-lose. Oh wait, they want exactly one game. Sorry, I read it at least one game. Sorry, so if it's exactly one game, so your probability of lose-win or win-lose. When you see the word or, by the way, be really careful. Or means plus, always. In probabilities, or means plus. Never mix them up. And means multiply. Like, so it's lose and win, or win and lose. So don't forget this. If you forget it, you're not gonna do well on your exam. So lose-win, it's lose 0.4 times 0.8. 4 times 0.8 in brackets plus win-lose, which is 0.6 times 0.2. And once you do all that on your calculator, you should get 0.44, which is your answer. And that's how you solve first question. So for simple questions where it's like two games, draw the tree diagram. It's gonna really help you visualize everything. And if it comes in a written, write it like this, right? Probability of win-win, and then start solving. Probability of lose-lose, like, because my teacher said they might be strict about these little rules or things like that. So to be on the safe side, write it in this way, okay? Now I was just showing you for this question. The rest of the questions I won't solve it like in this way, probability, win-win, whatever. But I was just showing you an example on the easy questions. Now, next question. Okay, so Dina chooses one card at random and doesn't replace it. And then she chooses another card also at random. So Dina has four cards that have the number 4 or 7. So her probabilities of picking out a card, she'll either get 4 or 7. The chances of her getting 4 are, you have to count how many 4s there are. 1, 2, 3, 4, 5 out of 8 cards. So her chance of getting 4 is 5 over 8. And the chances of getting 7 are 3 over 8. So then she's gonna choose another card and not replace it. If you're not replacing something, you're gonna have less. What I mean is, like, look, when you're gonna pull out another card, again, you could either get 4 or 7. You don't have much options. And when you choose it, it's gonna be out of 17 now because you already removed the card and you're not putting it back. So the chances of you getting 4 is 4 over 17. Why 4? Because if you picked one out, you have less cards. Because if you picked out one less 4 card, you have one less 4 card, but for this, it's still gonna be 3 over 7 though. It's always over 7 if she does not replace it. Or like always minus 1 of what it was here. And here, if she pulls out 7 first try, she can either get 4 or 7 again. And her chances of getting 4 are 5 over 7. And her chances of getting 7 are 2 over 7. So now that we have our probabilities for all cases in the cards, what's the probability of that you get 2 cards with the same number? So it's either your probability of 4-4 or your probability of 7-7. So see, 4 and 4 or 7 and 7. So now let's see, probability of 4 and 4, which is 5 over 8 times 4 over 17. 5 over 8 times 4 over 17. 4 over 7, my bad. So this is your 4-4 probability, or, which means plus, you get 7-7, which is 3 over 8. Over 2 over 7, times 2 over 7. And guys, put it in your calculator in this way, it's more likely going to give you the right answer. And when you put all of this in your calculator, you're going to get that it's equal to 13 over 28. So what you do is you draw a simple tree diagram and read the question really well. Make sure if it's something where she's choosing, make sure is she replacing it or is she not? That's one factor you have to be careful about. And you have to read what they want. So 2 cards have the same number. You always have to analyze your question and what it wants. So that's just how you do it. Okay, so now on to the next question. So now this question, you are in a factory and you're assuming that 20% of all products are defective, which means broken, and that you inspect the items until you encounter the first defective item. So your chances in this factory is you either get a defective or not defective. Defective or not defective. This line means not. So the chances that you get defective is 20 over 100, because 20%. You could use the decimal points for it too, by the way, guys. And the chances you get non-defective is 80 over 100. So now let's see. What's the probability that the first defective item was encountered when the third item was inspected? So we need to assume that your first two were non-defective and that your third one was defective. So we're gonna do here 80 over 100, which is the non-defective, because you need two items that aren't and one that is. So 80 times 100 over 100. And then you square it by the item. Like if it's the third item, you do 3 minus 1, and that's your power. If it was by the fourth item, you do 4 minus 1, and that would be your power. 3 would be your power. So that's what you do when you see like this. So 80 over 100 times the third one being defective, which is 20 over 100. 100. Now when you put this into your calculator, it's gonna probably give you 16 over 125. Yeah, you're probably gonna get 16 over 125. Now you're gonna say, oh no, it's definitely wrong. It's not. It's just you have to make them same denominator. So here they want it over 1,000. You do 1,000 divide by 125 on your calculator, you're gonna get that it's equal to 8. So you need to multiply both sides by 8. So divide by 125 equals 8. Now you need to make them like denominators. So times 8 times 8. When you multiply up and down by 8, you're gonna get that 16 times 8 is 128, and the bottom is gonna be 1,000. So it's 128 over 1,000. And that's how you solve first one. So second one, the probability that the first defective item was encountered before the third item. So it's either you got it by before the third item means less than 3. Less than 3 is not including 3. So it's either that you got it first try or second try. So we have to add up our possibilities for both. The possibility that you got it defective on your first try is 20 out of 100, because that's the probability that you have a defective item. So it's 20 over 100. But let me make sure I'm doing it right. So it's 20 over 100. Yeah. Or you could get it on your second try, which your chances for that would be 80 over 100 times 20 over 100. Because if we're doing it second try, you're going to assume that your first one was fine and that your second one was the problem. So then you have to do 80 over 100, which is your first one that was fine, times your second one that wasn't. So times 20 over 100. And I like using brackets because they actually just make everything look good. So now I solved it for some reason in decimal, so I'm gonna write down, so you're gonna be 0.2 times 0.16, which is the answer when you do this. You're gonna get that it's 0 over 32, 0.32, I mean. And they want it over 100, so you multiply this by 100. So your answer is gonna be 32. Sorry, 36, 36. I don't know how I added that. 36 over 100. Because like 0.2 is the same as 0.20, by the way. Like, to make it easier to your eyes to see it. So 36 over 100. Now part C, it's asking you what's the probability of the first defective item to be encountered after the third item. So you're gonna consider the probability that you got it on the fourth try, or anything after the fourth try. So you're gonna do. You're not gonna actually count it as fourth try. You're just anything after third try. So you're gonna assume that you had 3 successful tries. You didn't get a defective item in your first 3 tries. So you have to do 80 over 100 times 80 over 100 times 80 over 100. But to make it easier for you guys, just do it cubed. So when you do this in your calculator, you're gonna probably get 64 over 125 for 125. And again, we said 1000 divided 125 to get like denominators. You need to multiply by 8 up and down. You're gonna get 512 over 1000. So 512 over 1000. And now you solve this question. So on to the next question. So quickly just recap. You either get defective or not defective. For before third time, you need to do 3 minus 2, and that's how many times you didn't get it defective, times the time you got it defective. So you multiply it by 1 defective time, and the rest that aren't defective, and you have to make it like denominators, so you multiply by whatever makes the denominators the same. Second one, you have to assume that it's either the probability of defective, and it's either a probability that you got defective, because they told you stop when the first defective item is encountered, or you got it probability of not defective and then defective. Like, these were your 2 chances, okay? So that's what you had to calculate. The probability of defective plus the probability of not defective. And third one, it's just how many times you need to multiply this as your power on how many times you didn't get it defective. Now, next question. Okay, so Andy was trying to pull an apple off a tree. The probability that he's able to remove the apple is 2/3. So this is the chance he removes it. So he could either remove it or not. Remove or not remove. The chance that he removes is 2/3. And the chance that he does not remove is 1/3, because it's whatever left. So what's the value of k that Andy removes the apple 3 times in a row? So 2 times 3, 2 over 3, times the number of times he removed it in a row, or like to the power of it. So 2 over 3 cubed, you're gonna get 8 over 27. Or 27. Now for B, what's the value of M, that probability that Andy removes the apple at least once in his 3 trials? So at least once in his 3 trials means you need to calculate what's the probability that he gets it. You need to do 1 minus, like memorize this rule, at least once. So minus the probability of the times he's not able. Minus probability of times not able. Not able. Okay, so now let's do our thing. So it's equal to 1 minus 1/3 over 3, 1/3 power 3. Because you're gonna calculate it by the probability of the times, how many times he's not able to do it. Okay, and then you're gonna get it 1. I'm gonna make it as a fraction, 27 over 27 minus 1 over 27, because that's your 1/3 over 3. You get 26 over 27. And yeah, that's how you solve this one. Now, okay, so quickly, what we did was you need to use this rule. If you want the at least one time, if it says at least one time, you do 1 minus the probability of the times not able. So you need to do it 1 minus the probability of how many times you tried. So it's 1 minus 1/3 cubed, because you tried it 3 times, and the probability of you not getting it is 1/3, and then you get your answer. I'm just gonna use this up. Okay. So what's the value of n that Andy removes the apple in exactly 2 trials? So what are our probabilities that he, wait, let's see, that he removes it, because he wants exactly 2 times. They want exactly 2 times. So it's either he removes it, doesn't remove it, or he doesn't remove it, removes it, or that he removes it, doesn't remove it, and removes it. So these are your probabilities, that what they want. So what you need to do is 2/3, which is your chances of him removing it, because you have 2 times where he does remove it. 2/3 power 2, because that's how many times he has to remove it. Sorry. So you multiply it by the time he doesn't remove it, which is 1/3. You're gonna get 4 over 9, or 4 over 27, sorry. So this is your chance for one time. This is for one of these. So this is the chances, this is the probability for only one of these scenarios. So since you have 3 scenarios and this is the probability for one of them, you need to multiply this number by the different scenarios you could have had, which is, in this case, you could have had 3 scenarios, so we multiplied by 3. So 12 over 27 is your answer. So really quickly, the value that Andy removes it in exactly 3 times is 2 over 3, which is your probability that he removes it to the power of how many times he tried. And if you want at least, you do 1 minus the times you weren't able to, and then you'll get your answer. And if you want exactly 2 trials, or exactly no matter how many trials, you write down almost all your scenarios and you find out how many scenarios do we have for this case, and then you do you solve the probability for one scenario and multiply it by the number of scenarios you have. That's how you solve this question. Okay, so this question, it's really easy. So the probability of obtaining, you have biased dice, so your dice aren't equal, they're broken, they're not going to give you correct answers. So the probability that you get sum 12 is 136, 11 is 236, 10 is 336, 9 is 436. What's the probability of obtaining a sum of 9 or 10? So you have to do sum of probability of 9 plus probability of 10, because the word or is keyword for plus. So what's your probability of 10? It's 3 over 36 plus 4 over 36. 3 over 36 plus 4 over 36 equals 7 over 36. And that's it. That's how you get your answer. This is probably the easiest question in this quiz. So next question. Okay, so you have a jar and it contains 12 red, 8 blue, and white, and 4 white marbles. Each marble is picked in succession at random. Each color is noted and put back in the jar. So they put them back in the jar, so you're not missing any. So what's the probability that all 3 marbles they picked were white? So they picked 3 marbles. What's the probability that it's white? First of all, we have to calculate our probability that we get white marble in general. So you either get 12, you either get red, white, or blue. Red, blue, or white. Probability of red is 12 out of 24. You have to add 12 plus 8 plus 4, which is 24. So that's your probability of getting red. Probability of getting blue is 8 over 24. And your probability of getting white is 4 out of 24. 4 out of 24. This number is supposed to be 4, doesn't look like it. So now you want the probability that all 3 marbles picked are white. So you just take this probability, which is 4 over 24, and you cube it, because you picked out 3 times. And that's your probability. You get 1 over 216 when you do it. Yeah, that's it for this question. Because this is only possible because the marbles are placed back in the jar. If the marbles aren't placed back in the jar, you need to do 14 times 4 over 24 times 3 over 23 times 2 over 22. Then it's different. So just since they asked, since they place them back in the jar, you just take this probability and you cube it, or power to how many ever times you picked marbles, how many marbles you picked. So next question, they're telling you have a jar that contains 20 blue and 8 white. So you could get blue or white. (20 over 28) is your chances for blue, and your chances for white are 8 over 28. Now, what you have to do is, so telling you they picked 2 marbles right after each other. So after they picked the first one directly, they went and picked another one. And each time they noted the color and put it back in the jar. So be careful, it's placed back in the jar. What's the probability that you're getting at least 1 white marble? So the chances you get at least 1 white marble, at least 1 white marble is, you could either get blue white, white blue, or white white. So we have to add up all our probabilities for all 3 cases. So let's start with blue white, which is 20 over 28. Wait, sorry, why did I draw brackets from hand? Okay, times 8 over 28 plus 8 over 28 times 20 over 28 plus 2 white, which is 8 over 28 times 8 over 28, which is going to give you 24 over 49. So this is how you solve it, but I'm gonna really quickly just check something and I'll be back. Okay guys, so I also now realized the other way we could do this. I was just checking if it's right. Or you could do the rule I just showed you in the previous question when it says the word at least. At least means 1 minus probability of the times you weren't able to get the white. So, which here is one case. Both ways are easy. Just whatever way makes you feel better or like more confident with your answer, take it. If you want, you could use one way in your solving and the other way to check your answer after you're done your exam. Whatever you want. I'm just going to give you both ways. So 1 minus probability of times not able, which means 1 over what could you not have gotten white in. The only case where you couldn't have gotten white is blue, right? So there's literally only one case where you couldn't have gotten white. Because in every other case, you would have gotten a white. But blue, you wouldn't have. So we have to calculate our probability of getting blue twice, which is 20 over 28 for one blue. And since it's two blues, you're squaring it because your probabilities don't change. And when you put this into your calculator, you're going to also get 24 over 49. Use whatever way makes you feel better, whatever way makes you less stressed in the exam, use it. Whatever way you're more sure of. And to check, you could use the other one. It doesn't really matter. They both give you the same answer. So you could either take all your probabilities and add them up for white. This is blue-white. This is probability of blue-white. This is white-blue. And this is white-white. So you add up all these probabilities, or you do this formula thing. Both will work. Okay, so you have a team of 14 boys and 10 girls. The coach randomly picks two members, one after each other. So what's the probability that the two members picked are girls, both of them? So you could either pick boy, girl. So 14 over 24 guys. And there's 10 over 24 girls. What's the probability that both the members he picked are girls? If it's decreasing, by the way, because if you pick out a girl from the team, that's one less girl you have to pick out of. So it's 10 out of 24. Times, wait, let me just question 8, yeah. Times, because look, if you're choosing another girl, you can either get girl or boy second time, but you're gonna have one less. So it's now 9 over 24. 9 over 23, because you have one less person to choose out of, or 14 out of 23. But you don't need to draw the tree diagram for every question. So 10 over 25 times 9 over 10 over 24 times 9 over 23. And when you do that, you're going to get 15 over 92. Don't try to solve anything mentally. Like, you're going to get mistakes. Definitely prone to error in these types of questions. And since we're allowed calculators, why not use it? So that's how you solve this question. And yeah, that's it. Now, next question. How many ways can one girl and one boy be chosen from a group of 16 girls and 10 boys? So if you have 16 girls and 10 boys, to find out how many combinations you could have, you just multiply them. 16 times 10. You could choose them out in 160 different ways. Which means girl, boy, 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 girl, girl. There's 160 different ways you could choose from them. So 160 ways. It doesn't have to be two people, by the way. Like, you could have, if it's this many ways, you're not definitely choosing boy, girl, boy, 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 girl, girl. Definitely not. It's gonna be for more than one, but they didn't tell you how much. So you just multiply these two numbers to find out any answer like this. Okay, this question came in our AMS. It's easy, it should be. You have a wheel that's divided into 100 sectors, and this is your probabilities that you're getting any of these numbers. So what's the probability that the wheel stops at a sector marked by a number larger than 10? So you need to look at the numbers larger than 10 and see what's the probability. 10 plus 6 plus 1, it's 17. And out of 100 sectors. That's it for question part 1. Now for part B. What's the probability that the wheel stops by a sector marked by even number? So you go to all your odd numbers, cross them, remove them, like remove this, remove this. And add all the probabilities left. So 10 plus 20 plus 10 plus 1. You're going to add it really quickly on your calculator. You're going to get 41 over 100. That's it for these two parts. Now for part C. What's the probability that the wheel stops at a sector marked by a number larger than 10 or even? So you want number that's larger than 10. So all of these are accepted because they're all larger than 10. And even, or like you can look at even numbers. Well, so definitely not 5 and not 1, but 2 and 10 are even. So we add up these probabilities also. So 10 and 20, of course we have to add them, which is 10 plus 20 plus 10 plus 6 plus 1. You're gonna get 47 out of 100. Now let's make sure. Yep, 47 out of 100. Now last question in this quiz, then we're gonna go straight to 6.3 quiz. So now you have two spinners. The probability that you have two different spinners. So in this question, you have to make sure what spinner they're talking about. So here in this question, spinner A. Here it's spinner B. Here it's spinner A. And then we'll see the rest when we reach them. So let's start solving with these. So the probability that you get a number that is not 6 in spinner A. So we only have 1 6. So the chances that you don't get a 6 is 3 out of 4. That one's really easy. Spinner B, you spin it twice. The probability that the number is shown 5. So what's the probability to get 1 5? To get 1 5, your probability is 1 2 over 4. Now, if you're spinning it 2 times, you need to do this probability. You need to square it because you're doing it 2 times. You're going to get 4 over 16, which after you simplify is 1 over 4. Now, spinner A, this spinner, is spun 40 times. What's the estimate that you get 5? The result of how many times you get 5 when you spin it 40 times. So if you have the probability when you spin it once of getting 1 out of 4, like your probability of getting 5 is only 1 out of 4. That's your probability of getting 5. But when you spin it 40 times, you just multiply your probability of getting 5 for 1 time times the number of times you spun. So 1 over 4 times 40 is 10. Now let's go on to the second half of the questions. So D, let's go to it. So Dan spins the spinner B until he gets number 6. What's the probability that it happens on the 4th trial? Again, so we said, if you're happening on the 4th trial, you need to calculate the probability that he does not get the number 6 3 times, then he gets the number 6. So the probability, let's see first, what's the probability of getting number 6 in spinner what? Wait. In spinner B. What's the probability of getting number 6? It's 1, 4. And the probability of not is 3, 4. So let's go back down. So spinner, okay, sorry. Dan spins spinner B until he gets 4th try. So you need to assume that he did not get 6 3 trials. So he did not get 6 for 3 times. We said 4 minus 1, that's your power. And then you multiply it by the time he did get 6, or the probability it was to get 6. When you do that in your calculator, you're going to get 27 over 256. Just write your answer down. Now, last question. You don't need to look at the spinners for this one. Just fill in the table. If you do that, you're doing yourself a huge favor. So this is 8, this is going to be 9. What they're doing here, by the way, is adding this with this and writing it down. So 5 plus 4, 9. 5 plus 5, 10. 5 plus 5 again is 10. And 5 plus 6 is 11. Now 6, 4, 10. This is 11. This is 11. So you want a greater. Now they're asking you what's the probability that you get a sum that is even and greater than 9. So it has to be both even and greater than 9. So let's start erasing our options that it definitely couldn't be. Can't be 8, can't be 9, can't be 9, can't be 8, can't be 9, can't be 9, can't be 9. Because all of these are less than 9 or equal to 9. They want greater than 9. Or even. Now let's remove all our odd numbers. 11, 11, 11 is odd. And now you put a circle around all the even numbers or the numbers that aren't crossed, which is 10, 10, 10, 10, 10, and 12. Count how many red circles you have. 1, 2, 3, 4, 5, 6. And now you get 6 out of 16 options. Why is it 16 options? Because you have 1, 2, 3, 4 times 1, 2, 3, 4, which means you have 16 outcomes. And that's how you solve it for this question. Now, this is the end of 6.2. We're going to go to 6.3. Now, find the probability that you use this tree diagram, and you need to find probabilities again. So what's the probability that your student is late on their first day of school? If the chances that he's not late is 1 over 5, so the chances that he's late is 4 over 5. Because you do 1 minus this, you get your chances for the second one. Because we know they have to add up to make 1. So it's 4. Now, the probability that he's not late to school, if the probability that the student is not late to school on the second day is k over 9. So what's the probability that he's not late to school on the second day? So it's either that he's late and then not late. Wait, what? What's the probability of the student that it's not? What's the probability that the student is not late to school on the second day? Okay, yeah. So probability of the student being not late is, wait, I think I wrote it down wrong on my paper. Oh no, I didn't write it wrong. I just misunderstood the question. Okay, so the probability that the student is not late on the second day. So if the probability is he's late is 2 over 9, then this must be 7 over 9, which is 9 minus 9 minus 2 minus 9. That's what they meant. I understood the question wrong. So, and what's the probability that the student is late to at least one day? At least one day means he could be late, not late, not late, late, or late, to at least, yeah. So it could be late. So what we do here is We could do, like I said, two ways: our rule and the way we do it normally, which is we calculate the probability of late, not late, not late, late, and late, late. So 1 over 5 times 7 over 9. That's your probability of late, not late. You add it to the probability of not late, but then late. So 4 over 5 times 2 over 9 plus the probability of late, late, which is 1 over 5 and 2 over 9. 5 times 2 over 9. Which, when you put it into your calculator, your answer is going to be 17 over 45. Or you could do it this way, but let me really quickly do it on my calculator. Times 7 over 9. What? Wait guys, I'll be right back. You won't even feel it. Okay, turns out the mistake on my side was from my calculator, not me. Okay, so, or you could do 1 minus the probability of him not being able to be late, which means the only chance where he's not late at all is not late, not late. So you do 1 4 over 5, which is the probability of not late, not late, times not late, which is 7 over 9. That's a 7, not a 2. And that you're also gonna get for this 17 over 45. So you could do both ways. Both will work. Personally, I'm gonna solve it in one of these two ways and check with the other when I'm rechecking over my exam. So, and yeah, it's only 3 parts, yeah. So that's how you solve this question. Now on to the next. Okay, so Lee either walks or goes by bus to school. Probability that he goes is 3, 5, 1, 7. I'm not gonna read them because they wrote them down on our tree diagram that they gave us. So if the probability that Lee walks to school is expressed as, which is 5 minus 5, 5 on top, 5 over 5 minus 3 over 5, which leaves us here with 2 over 5. Now, see, 2 over 5. The probability that Lee goes to school by bus and that he's not late. I'm just gonna erase this. So the probability that Lee goes by bus to school, sorry, and he's not late is, we have to calculate. So he goes by bus and isn't late. So the chances that he's not late is 6 over 7, obviously. So the chances he goes by bus is 3 over 5. So that's the chances of bus, and that he's not late is 6 over 7. So you do 3 over 5 times 6 over 7. And you're gonna get 18 over 35. And that's how you solve this question, this part. See? 18. Now the probability that Lee is not late to school at all is expressed as, so you need the probability of him not being at all late to school. So it's bus not late plus walking not late. So you need to do your probabilities again. By bus, which is 3, 5. Oh wait, let me just see something. 3 over 5, 6 over 7. Yeah, so 3 over 5 times 6 over 7. And, or that. So this is by bus and not late now, or by walking and not late, which is 2 over 5. And not late is, here it's 2 over 7. Put all this in your calculator. You're gonna get that your chances are 22 over 35. When you scroll down, yep, 22 over 35. Now, next question. So now we need to solve for the probability of n. They didn't tell us this probability and it's uneven, like the spinner must be broken. So we need to find the probability of n. So you have 2n, and we know that all of these are going to add up to 15, which is our denominator. So first we have to make everything on the same denominator. So anything that's with the denominator of 3, you multiply by 5. Anything with the denominator of 5, you multiply by 3. So 1 over 3 is 5 over 15. Plus 3 over 15 plus another 3 over 15 plus 2n over 15. Because you have two n's and they're both over 15, so it doesn't matter. 2n over 15 equals to 15 over 15. So what you do now is you add all the terms you have, which now this is going to be 11 over 15. You could forget the over 15 because they're all over 15. So 11 plus 2n equals 15. So 2n equals 4. N equals 2. And that's how you get the value of n. Now Lee spins the spinner once. The probability of him getting 6 or 7. So it's 6 plus the probability of 7. So this is 5 over 5 over 15 over the probability of him getting 3 over 15. Wait, it's or, sorry. This isn't plus. This isn't time, it's plus. So your probabilities are 8 over 15. So that's how you solve first two parts. Now let's see third. Okay, so third is made out of two different things. So Lee spins the spinner twice. And the probability of the sum of the numbers being 17 is... Okay, so Lee, he spins twice. You want the 17, right? So you need to calculate. So how do you get 17 out of these numbers? It's either 7 plus 10 or 8 plus 9, right? Since now here we have same fractions, right? Actually, I'm not going to solve it in that way because it could be different numbers in the exam, and this way it wouldn't work if it's different numbers. So I'm going to solve it normal way. So to solve this question, you need the probability of 7 over 10, or 7 plus 10, which is the probability. So 3 over 15 times By the way, you first have to write down how could you get 17. So it's either 7 plus 10 or 10 plus 7. You need to make sure that you're calculating it for both 7 plus 10 and 10 plus 7, or you're gonna get a wrong answer. 8 plus 9 and 9 plus 8. These are your ways you could get 17. All of these equal 17. So since these two are the same and these two are the same probabilities, you're gonna first solve for each one, like one of these. So 3 over 15 times 2 over 15 . So you're gonna solve it for one of these cases. So I'm gonna take 7 over 10 for first case and 8 over 9. So plus the same probabilities, because they're the same, 3 over 15 times 2 over 15. And then you're gonna get 4 over 75 from this, but you still have two probabilities we didn't calculate. You still have these two, this and this. So you multiply this answer by 2 and you get 8 over 75, which is your final answer. Now, if and only if you have the same probabilities, so you're multiplying this like this, 3 over 15 and 2 over 15 two times, so you could do 3 over 15, but this is only if you have same numbers for each probability, okay? If you get what I mean, do it. If you don't, just stick with this. You're always gonna get the right answer. So you could do 3 times 2 over 15. All this times by 4. If you understand why I'm doing this, do it in the exam. If you do not understand why I'm doing this, just stick with this way. It's safer. It's gonna help you in all cases. So then you'll get the same answer, which is 8 over 75. And let's see, that is our answer. Now Lee spins the spinner 100 times. What's the probability that he gets 8? So if the probability for one time he gets 8 is, what's it called? 3 over 15, that's the probability for one time. If he spins it 100 times, he's gonna get it only 20 times. So that's how you solve this question. So part A, really easy. You add all of these and find out what's your n. Part B, also really easy. You just add these two probabilities together. And then part C, you do this way or this way, but only if you actually understand why I'm doing this way. And this way, you don't do it always, and only very some cases, okay? Like this one. But like I said, stick with the safe side to ensure your mark. Get this, do this way. And this way, you just do the probability for one time, multiplied by how many times you spun, you get your answer. Okay, so for this question, it's really easy. They want the probability of exactly one green and one red. So it's either red-green or green-red. So you add up the probabilities for both. So 11 over 20. Oh, by the way, second marble was picked without replacing. So it's gonna affect on the second trial. So 11 out of 20 times 9 over 19, because you're affecting it, because it's not replaced. Or you could get green-red, which is 9 over 20. times 11 over 19, which your answer is going to be 99 over 119. And that's how you solve this question. It's really easy. We solved way harder, so this shouldn't be that hard. This is how you solve it anyways. Now, how to calculate probabilities. So they're telling you 2 dice are rolled, and the sum that they land on is observed. What's the probability that the sum is less than 5 when it tells you? So it gave you a hint that it's less than 8. It told you it's less than 8. So we're going to go back to this. You've probably seen it a million times. I haven't done it again. This, in my opinion, is the first thing you should draw on your scratch paper. It won't take you time. It's really easy to draw. It's just the sums. If you haven't watched my previous videos, I do this because it's the sum. This is your space of outcomes. This is what we call it. So now this is for the dice. It told you your answer is less than 8. So anything 8 or after it, you disregard it. You don't even look at it. Now you look at these numbers and you add them all together. So you're gonna do 6 plus 5 plus 4 plus 3 plus 2 plus 1 to get how many are you over. So it's over 21 now. Okay, and they're telling you what's the probability that it's less than 5. So you don't count 5 or 6. What's the probability that's either less than 5? This, so you don't count 5 or 6. What's the probability that you get 4, 3, or 2? It's 3 plus 2 plus 1, which is 6 over 21. After simplifying, you're gonna get that it's 3. It's actually, no, 3. It's 2 over 7. So what you do is, if it tells you that it's less than 8, anything after than 8, disregard it. We don't even look at it. And if it tells you, if it asks you what's the probability less than 5, you don't count 5. So you don't look at 5, 6, or 7. We just look at 4, 3, and 2. You find the probabilities or the chances their sum is 4, 3, or 2, which is 3, 2, and 1. Add them. It's going to be 6 over 21. And how you get 21? It's by adding every possibility less than 8. So that's how you solve this question. Now, question 6. What's the probability that, okay, so we again have a jar with 28. Okay, I'm going to change color because it doesn't show on white screens. I'll use red. It's more. So you can either get blue or white. And you're not replacing. Chances of blue are 20 over 28. Chances of white are 8 over 28. So what's the probability that the second marble is white when it told you, you picked a marble and the first one was white? So we have to just continue this tree diagram a little more. So the chances are that you get blue if it's not replacing is 19. Oh, this is blue again, and this is white. And this is white, and this is blue. And this is white and white. So this chance is now 19 over 27. And this other one is 8 over 27. This now here is 20 over 27. And that one is 7 over 27. So what's your chances when it tells you your first one was white? So we don't even look at the first part of the tree diagram. This part, kullo, we disregard it. We look at the second one. If they tell you first one is white, what's the chances that the second one white? Just look at this number. 7 over 27. Done. That's it. You disregard the first one. Now, what's the probability that both are white? They're asking you what's the chances that both times you pick, you get white. So this is 8 over 27 times 7 over 27, 8 over 28 times 7 over 27. 8 over 28 times 7 over 27, you get 2 over 27. That's how you solve this one. And now we're on our last question. Should be easy. Yep, this one's really easy. So you have 100 single adults, and they were surveyed about having pets at home. What's the probability that the person has a pet given this person is female? So they told you we have a female, so this entire part we don't look at it. We disregard it. We don't look at it. We don't have a male. They told us it's female. So now you only look at this one. You add these two together to get what your what's the chances over. So your 24 plus 21 is 45. So you have 45 women in this case. So what's the chance that this woman has a pet? It's 24 over 45. And that's it. You just have to simplify it to over 15, which is 8 over 15. And that is it. So when it tells you that this person is male or female, or that your number is less than 8, or that you know your first one is white, you forget any other opinion. You can forget it. They told you it is. So here they told you it's a woman, so we don't even count the males as an option. So they told you it's a woman, so what's the chance that this woman has a pet? It's 24. Out of the sum of these, which is 45, you want it over 15, so you divide it to make it over 15, which means you divide by 3, divide by 3. And that's it for this quiz. I hope you understood everything. If you have like any extra comments or extra questions, ask it in the comments. And yeah, hope you have a nice day. Bye.